All right, good afternoon, everybody. Glad to see some of you made it back from lunch. Thank you for the intro, Patrick. So we all know that over the last few years, there's been an increase of Apple devices in the enterprise, particularly macOS platforms, things like that. And because of that, we've seen a constant increase in the amount of malware that's out there in terms of info stealers and things like that. But we've also seen increasingly sophisticated malware. We heard from Jaron and Ferdu yesterday morning talking about Blue Noroff and Rust Bucket. We've seen Joker Spy that's out there. You've probably seen the headlines of 3CX, Jump Cloud, the breach at Circle CI. So there's a lot of really active intrusions in the news. And because of that, we thought it might be interesting for us to walk through a couple of the intrusions that we've come across attributed to a North Korean adversary that's targeting the macOS platform right now. So with that. So quick intros, I'm Greg Longo, Ben Wiley. We're both senior intrusion analysts at CrowdStrike. We work on the Overwatch team, which is the managed threat hunting service. We do 24/7 threat hunting, and our job's focused primarily on nation-state adversaries. We've been there for the last few years. That's where our focus has been. And we've been, let's say, over the last 12 to 18 months, spending a lot more time looking at macOS intrusions. So today, we will take you through a brief adversary overview. We'll talk about the tools and tradecraft of the adversary that we're going to talk about. We'll describe some of who they're targeting, why they're targeting, what that looks like, so you're generally aware. And then we'll walk through a day in the life of a DPRK operator and kind of show you not so much the malware. We'll talk a little bit about it, but we are not malware analysts. But we'll look more at the behavioral aspects of what this adversary actually looks like once they land on an endpoint and start conducting operations. So hopefully it's a little bit of twist on the things that we've been hearing about from a slightly different perspective, but hopefully you find that interesting. So with that, we'll go ahead and jump into it.
Thanks, Greg. So LABYRINTH CHOLLIMA is one of the most prolific DPRK-nexus threat actors. They've been active since at least 2009 and have a dual mission of both intelligence collection and currency generation. You know, a lot of that currency that they're generating along with the other DPRK threat actors helps pay for things like the North Korean nuclear program. They've been responsible for some of the more high-profile attacks that you've probably heard of in the last almost 10 years, I guess, or more than 10 years overall. But the Sony Pictures attack of 2014, that was LABYRINTH CHOLLIMA. And then more recently, as Greg mentioned, the Jump Cloud and 3CX attacks were both attributed by CrowdStrike Intelligence to LABYRINTH CHOLLIMA. Some of the verticals that we at CrowdStrike Overwatch have seen them target in the last year have been the financial and technology verticals. Now, a lot of those have been cryptocurrency organizations that falls under that currency generation mission. But we've also seen other more traditional technology companies, big names, be targeted. And then some of your more classic nation-state targets like government agencies, media, energy, manufacturing, defense industrial base, things like that. On the right here, you'll see a graph of basically CrowdStrike's current understanding of North Korean cyber warfare structural organization. So this is the Reconnaissance General Bureau's third bureau. And the RGB is responsible for all of North Korean like intelligence collection, clandestine operations, things like that. And you see in the bottom left, you have the 110th Research Institute, which correlates roughly with what OSINT has dubbed Lazarus Group. And within that, CrowdStrike Intel tracks two separate elements. Stardust CHOLLIMA, which Jaren's talk on Blue Noroff and the Rust Bucket malware, that was Stardust CHOLLIMA. And then LABYRINTH CHOLLIMA, who we're talking about today. You may think that's all good and well, but what the hell is a CHOLLIMA? A CHOLLIMA is a mystical North Korean winged flying unicorn. And then you might wonder, why were you getting these names like Labyrinth and Stardust? Well, that's because there was a CrowdStrike Intel analyst who was a big David Bowie fan. So that's where we are today. Labyrinth CHOLLIMA maintains a pretty extensive tool set, a list of malware families that is a Jira page long, basically, spanning Windows, Linux, Mac OS, and Android. They're known for their ability to develop new capabilities, new malware families very rapidly, in large part because of the use of a malware framework that spans all, or at least Windows, Linux, and Mac OS. That malware framework is called the HOBUP framework. Prior to 2015, I believe, Stardust CHOLLIMA and Labyrinth both operated off of the core DLL malware framework. But at that time, there was like a reorganization in North Korean cyber warfare structural organization. And Labyrinth started using a derivative of that called HOBUP. And Stardust started using a derivative called 2pence. An interesting fact about these two groups, or about Labyrinth, I should say, is that the tooling that we've observed them use over the years has typically differed depending on if the target was for intelligence collection purposes or for currency generation. So you would see different malware being deployed, likely different operators and different malware authors, depending on what mission they were going after. But all of that malware still fell under that HOBUP framework. So it was still Labyrinth CHOLLIMA, just a different subset of malware authors and operators. Targeting. So in a recent report by Chain Analysis, they said there was over $1.7 billion worth of cryptocurrency stolen just by DPRK operators last year. There's been a sharp uptick in the tempo of targeting cryptocurrency organizations since the pandemic. I heard a podcast with this CIA officer who said that more harm was done to the North Korean economy by the self-imposed border closure at the very start of the pandemic than sanctions put against North Korea by the West have ever done. And so they are economically hurting, and we have seen the uptick in cryptocurrency targeting, that's on pace with that. Targeting, going years back, was mostly focused on cryptocurrency exchanges, some of those really big names, where there's loads of crypto stored and hundreds of millions of dollars are stolen at a time. But as time has gone on, they've brought into smaller exchanges or just like crypto adjacent sort of targets, like online gaming perhaps, where they have access to large amounts of crypto stored in wallets, but it's not a crypto exchange. They just utilize that as part of their business. And so a lot of the targeting we've seen, especially in the last 12 months, has aligned with that. Typically, anytime we're seeing them go after a crypto org, though, what they're trying to do is the same every time. And you can see it play out, if they're allowed to maintain access. They're looking for the private keys to crypto wallets. And once they find those crypto wallets, once they have the ability to transfer crypto out, they're doing it, it's fast, it's going to threat actor controlled wallets, and then they're trying to launder it, and make it harder for organizations like Chain Analysis to track that crypto. So why Mac OS? Why have we seen such an uptick in Mac OS targeting, specifically in the last 12 months in particular? Well, this is an old number, but in early 2021, there was a study that said 23% of the enterprise market share was Mac OS devices. I'm sure that number has gone up over time, but I think the primary reason we're seeing this uptick from Labyrinth CHOLLIMA in particular is the fact that a lot of these crypto organizations that they're targeting so heavily are primarily Mac OS fleets. These are newer companies. A lot of them are startups or were considered startups not long ago at all. They don't have 30 years of legacy infrastructure baggage that they are taking care of. They're primarily Mac OS and then the cloud. And so that's why I think we've seen such an uptick. And then also, when when Labyrinth is targeting macOS devices, they know that on the other end of that host is an end user. It's not a web server. It's not a Linux box. It is a person on the other end. And Labyrinth and the other Chollima groups, they care very much about who that end user is. And they put a lot of time selecting specific people to target, often via LinkedIn, because who that person is affects how they're able to social engineer them and then what access they'll have once they have malware deployed on that box. So the number one target that we've seen in the last year at these crypto companies in particular has been developers, back-end engineers, people like that. Because right when they get access to that macOS system, they know that person probably has access to their cloud environment. They probably have the credentials necessary to make shit happen, And so that's why I would say predominantly, if it's a crypto organization, or really any big tech firm that we're seeing is targeted, the most common target is a developer, an engineer of some sort. We've also seen Labyrinth target C-suite folks, which again, I think more often you're seeing macOS devices assigned to the C-suite just because they can. Sales, we see them targeted as well, and a lot of those folks have macOS devices. And I think one reason they're targeted is because salespeople are often expected to interact with people on the outside. They're looking for those leads. They're wanting to talk to folks. And so they're more likely to engage, whether that be in LinkedIn chat, more likely to click that link, open that attachment, et cetera. And then also security researchers. There's probably someone in this room, perhaps more than one, that has been targeted by Labyrinth Chollima or another Chollima group in the last few years. There's been multiple reports of security researchers being targeted by Chollima groups because they either want to know what you're up to or they want to steal your 0-day, things like that. So, let's start talking about what this activity looks like on the host. So the intrusions we're going to talk about today were conducted between late 2022 and early 2023. These were intrusions that we at CrowdStrike Overwatch saw. And the primary capability that Labyrinth leveraged during these intrusions was the MataNet implant. That's a malware family that's been around for a few years, but hasn't been talked about that much, in open source. And then the two organizations we're going to talk about were in the financial and technology verticals, one of them being a crypto org and the other just being more strictly technology. So MataNet is a cross-platform modular implant framework that's been in development since at least 2018, maybe longer, and has been in use since that long as well. It started out with just a Windows version, but over time we've seen Linux versions pop up, Mac OS versions pop up. You may have heard this malware referred to by other names like Dackles, Mata, or the recent Mandiant report identified it as tie-dye. And this malware was designed with OPSEC in mind. It's fully dependent on plugins for all of its main functionality. Those plugins can be bundled with the payload. They can be embedded into the configuration file, or they can even be downloaded on demand as needed. And what this allows the operator to do is not expose any more code than is necessary, given who the target is, what features they anticipate needing. And we will see at times limited functionality be delivered initially because they don't expect they'll need it. This malware is also features AES encryption for its configuration, the plugins, and the C2 communications. So clearly they care about covering their tracks or not being identified. Some of the more unique features include the ability to establish network tunnels and proxies, file compression and upload, secure deletion, which as a technique we generally associate with Chollima operators, not just Labyrinth, and then time stomping. We've also seen this malware bundled with like fake or Trojanized applications, which I'll talk about more in a second. But oftentimes we see this more as like a third stage payload, that final implant that's being delivered on the host. So we're not going to talk about the initial access necessarily for the 2 intrusions we're going to go over, but kind of wanted to give you a brief understanding of like what initial access often looks like from Labyrinth Chollima. So you've heard about the supply chain compromises as of late, and obviously I think that's something they're very interested in and pursuing on a larger scale than they were previously in previous years. But even those supply chain intrusions had to start somewhere else, and if you go back far enough, it will probably be phishing. And we have seen phishing, of course, via email very often with Chollima. It's over LinkedIn, and then they move to WhatsApp or Telegram, and where they feel perhaps a little bit less monitored. And then we've also heard reports from customers, since this is not something we can monitor, of their engineers, their devs being targeted via text message, via phone and phone number. And we've received the phone number from the customer saying this is who it was. And a lot of these lures that they're using will be employment-related lures. The threat actor is posing as a recruiter for a big tech firm that you've likely heard of, or a competitor crypto firm, and they're presenting, the target with like a job application, and then oftentimes we've seen recently these backdoored like coding challenges. So it's maybe an NPM package or a GitHub project that they're instructed to download, and then once it runs, it executes. It oftentimes is like a coding challenge, and the target victim will use it as such, but eventually it will beacon out and download further malware. And we've seen backdoored PDF readers, PuTTY terminals, VNC clients. But one of the more common and more interesting initial access techniques that we've seen Labyrinth perform over the last several years has been the use of these malicious crypto-themed applications. So a great example of that, although not that recent, was the Apple Juice campaign. Apple Juice is the downloader malware that is embedded in various legitimately like working applications. So in this case, this application that was, like I said, legitimately it works. It's based off of an open source application called Qt Bitcoin Trader. This version, the malicious version, was called CLUS Trade Pro. It contained the Apple Juice downloader. The threat actor goes to the effort of creating a pretty legitimate looking website with links to a Windows version to download, a macOS version to download, and it says there's a Linux version coming. They send out pretty well-written spear phishing emails across the industry to targeted individuals. And then they even went to the trouble of creating a LinkedIn profile for a developer that works at this fake company. And then, funny enough, this fake developer at this fake company, all put together by Labyrinth Chollima, his Twitter account is still up, and you can still go there. It's weird to me. It's like some sort of time capsule. It's artifact from an intrusion that's just still there. So that was 2021 that we saw that Apple Juice campaign, but this is still a very common tactic. And the 3 screenshots you see on your screen right now are all for, I think, the websites of applications that we've seen in the last 6 to 12 months. These were all malicious Electron applications. 2 of them were like cryptocurrency arbitrage applications. The one on the top right is a fake crypto wallet application. And similarly, they all had like a website in an application, and it just goes to show the great lengths that Labyrinth Chollima will go to make these this initial access vector work for what they do.
All right, thanks, Ben. So now what we're going to do is we're going to dive into 2 intrusions that we saw, taking into account what Ben described in terms of Labyrinth Chollima and how they operate. So skipping over the initial access, presuming it was largely social engineering to get initial, an installer on the box. The first intrusion that we're going to go through is a cryptocurrency organization. So basically what we saw is a user get phished or social engineered, and they downloaded this application called Payroll System. It was an ad hoc signed universal binary that the user ran, and basically all that did was spawn a shell that reached out and downloaded a second stage implant for them, for the actor. Basically what that did was just execute an NS task, the class, to launch this script, which you can see basically conducts the same actions there. And we see their second stage at the end, which executes. Again, launches another bash shell, and we see the operator actually conduct a bit of light reconnaissance, looking at the user's directory, looking to see if this hidden file actually exists within the user's directory, this .aws CLI, which at first we didn't really understand what that meant until they had some more follow-on, and then running swvers to check out some system information. So again, using their Safari agent implant, launch another bash shell, and they conduct some additional activity. Basically what they do is they write two hidden files, AWS CLI and npm audit, both hidden files in the user's directory, make those executable. They launch them with this -- daemon option, and then go on from there. They then basically check out the Postgres SQL directory. They want to see what's in there, and we can see them move one of their implants, .npm audit, from the user's directory over to PSQL tool, which for those of you who probably know, there's a PSQL binary, but not a PSQL tool binary, right? So they drop it in there trying to look legit. They modify the permissions of a plist that they dropped on the system, this homebrew mxcl.postgres helper.plist. And then they take a look at that plist to make sure it's got what they need before going further. Basically, this is pretty standard for Chollima plists that we've seen for persistence. A couple interesting things to note here. So obviously run at load just to kick this off when the system boots and the user logs in. But then interestingly, the keep alive, for some reason, the keep alive key is always set to false in these plists that we've seen, which I don't know, seems a bit unique that you know, if the implant were to get killed, it wouldn't try and restart. But that's something that they typically do. So from there, we see them conduct a bit more reconnaissance. Again, just running a netstat command, which you know, we end up noticing is, you know, that particular command line ends up being a bit unique to them in terms of how they've constructed it. Directory services command line utility, so they execute that to dump a bunch of output from the user, run a few other commands, and what they do then is they use their implant, which again has the capabilities that Ben mentioned, to archive this up and then use the implant to exfil it off. So we see the creation of zip archives on the system, and then those disappear. So out the door that information goes. So one more intrusion, a little bit more in this one. So this one's at a technology organization, and this one actually starts before we were on the system. So we don't really know where they initially came from or how they got access, but where they ended up was actually in a JAMP script. So there was a JAMP script to uninstall McAfee on the system, and at the end of the script, there was this addition that they made. So basically a curl command to go out, pull down one of their implants, again, make it executable, and execute it with that -- daemon option as we saw in the past. So using their implant named JAMPD, trying to blend in, they basically make a copy of it. They call that copy Adobe Agent. And then they spawn another shell, and they create another plist on the system, and they try and blend in with the Adobe process. So com.adobe.armdc smjobless daemon. So we know that the smjobless daemon doesn't exist. smjobless helper does. but clearly trying to blend in with the Adobe process on here. And then they load that plist. So again, this is what their plist looks like. You know, we can see the keep alive is set to false, and their plist is set to execute that Adobe agent implant at user local bin Adobe agent, which is where they made the copy. So they run the plist, Adobe agent implant runs, spawns another bash shell, and from here they continue to conduct you know, additional reconnaissance on the system, kind of similar to what we saw in the previous intrusion, running some basic commands that we see across Linux or macOS, gathering some system information. We can see their netstat command that's run again, the same construct as before. This time we actually see them start to query credentials in the users directory, so looking at the shell history, looking at SSH host keys as well, to see what they can grab and what they can use. They run the DSCL command again. This time they've got a typo in it and they rerun it successfully. And interestingly enough, they output their command to this hidden log file in /temp. So you know, one of the things that Ben mentioned is that we do believe there are different classes of operators within the organization. You know, I think depending on the intrusion that we're looking at, we may see that in terms of the commands that these guys run, how they run commands, things like that. But this one was a bit interesting. Again, using Adobe Agent, they decide to drop another implant, which at the time we didn't realize what this was. Basically, they're using their Matanet implant to drop a copy of what CrowdStrike refers to as Ghost Ship, which is another implant framework that they have. And then they use their Matanet implant to you know, set that executable, and they launch that binary, spawns another shell, and they go back to their persistence mechanism, right? So again, they're looking at this com.adobe.rmdc, sm jobless daemon. What they end up doing is modifying that plist to then execute a different file. I thought I had it in there. Okay, again, so using Ghost Ship, spawn another bash shell. Now this one gets a little bit, I'm going to step through this one line by line because it gets a bit messy in terms of what they're doing. And to us it looks like what they were doing was effectively hijacking a legitimate plist. So they start off by moving the legitimate jobless helper binary to sm jobless help. So they basically take that and they set it aside. They want to make sure that they've got sm jobless helper there, which is actually part of their implant framework. And they set that executable. So right now, the legit sm jobless helper binary has been set aside, and now their malicious one is called sm jobless helper. From there, they load the legitimate com.adobe rmdc sm jobless helper plist, which legitimately exists on the system for Adobe, and that's going to launch their implant. So they do that. Then they unload it. And then they decide, well, maybe that wasn't a good idea. Maybe they thought they were going to get caught by doing that, or someone would pick up on it. So they take their implant, sm jobless helper, and they set that aside, right? So they move that to sm jobless helper _, and then they take, again, the legitimate Adobe binary, and they move it back, right? So then they switch gears and they go to another application. So they look at the Adobe GS service binary, which is the genuine software binary that checks to make sure that the Adobe software running on your computer is legitimate. So the legitimate AGS service binary is moved to AGS services. And then they take their implant, which is sm jobless helper _ at this time, and move that to AGS service. And check to make sure it's there. They make sure it's executable. And then they unload and load the AGS service plist, which will then now legitimate plist, but it's configured to launch their implant. So again, this kind of goes back to you know, which operator are we seeing on the keyboard? How are they doing things? Clearly, they're trying to blend in, but this is an interesting technique that we've seen them use across multiple intrusions, where they will take a legitimate plist that's on the system and hijack that to execute their implant. So a couple random encounters that we had that didn't really fit neatly into either one of those intrusions. We've seen them use a variety of signed and unsigned binaries. So I mentioned the one binary, the payroll system loader that they had was ad hoc signed. That tends to be a pretty common thing for them. A lot of their binaries just aren't signed at all. And we have seen them use legitimately signed binaries that's basically they've compromised somebody's team ID and use that to sign their own binaries. So going back to targeting, when we see them target engineers and software developers and things like that, yes, to get into the systems, to see what they have access to, but also there's probably an element of that with them stealing code signing certificates and things like that so that you know, they can make their stuff appear a bit more legitimate. So that's been really interesting. This line that's up on the screen was actually a command that we saw them run once they're on a host. Maybe they're having trouble getting their binary to execute and thought, hey, if we sign it real quick, maybe it'll work this time. But they've got that. We've also seen them doing credential harvesting. So in one instance, they used a NS Alert class. They named it Falcon Update. So, you know, like Jamf trying to blend in, they're going to use our own name against us, Falcon. And so Falcon Update with a config file there, basically what that does will just flash a prompt to the user to say, you need to enter your password to continue. And then they'll take that password and store it off into a clear text file on the file system. So that's one technique we've seen them use. We've also seen them attempt to use authorization plugins. I'm not sure how much success they actually had in this, but in one scenario, or one intrusion, excuse me, we did actually see them try and install and configure an authorization plugin to steal credentials. TCC, which we've heard about throughout the conference already. So interestingly, we saw them at one point attempt to dump the access table from the system TCC database. We didn't really see them do anything in follow-on actions that would lead us to believe they gained any that was successful, or we didn't really see them do anything that was apparent that they gained information from that. Also have seen them try and copy their own version of a database over to the system TCC database. And then lateral movement. So we saw, you know, again, we saw them looking at credentials in shell history, looking at SSH keys. In one intrusion, we did see them actually move laterally to some AWS systems. So they basically were looking at shell history, got some keys, and then used those to then query a couple different AWS hosts that were out there. So definitely, you know, being able to find information on macOS systems that they can use to move laterally and carry on further actions on objectives there. Okay, so a couple of analysis hurdles that we ran into in looking at these intrusions. Over the course of the last 18 months, as we've been watching Labyrinth Chollima, Stardust Chollima, the various Chollimas that are targeting macOS, they do have evolving TTPs. You know, so what we'll do is we'll see one intrusion, we'll find something that looks interesting, we can create detections based on that and hunting methodologies, and then as they quickly pivot and they do something else, those things become very, very brittle. So, you know, we've had to try and keep up with the things that they're doing. For example, going back to the TCC database dumping, we saw them do that once. We wrote some patterns for it. We saw them do it a second time, and then that was it. They moved on to something else. And they've done that in a variety of cases. So that's challenging. Obviously, having the telemetry, making sure that we're on the endpoints, or making sure that, you know, you have visibility of the endpoints that are in play, and you know, ahead of time, so that you can gather this type of data. Their activities are fairly low footprint, so there isn't a whole lot to detect necessarily, not like some of the other adversaries that we see, like China Nexus adversaries. And it's not a smash and grab operation that these guys conduct. They are very diligent and they're very OPSEC aware. So they do have, you know, the implants that we're talking about are all multi-stage implants. So they will drop a stage 1 and run some initial recon to see if that's even a system they want to be on before they drop a second stage or a third stage. So, so a lot of the activity can be very, very low footprint in terms of hands-on keyboard that we see. Obviously, they use native binaries, living off the land, like any of the intrusions that we see these days. That becomes very challenging. You know, if we see a command that we think this looks fairly unique to an intrusion, we'll run across our entire data set, and maybe unsurprisingly, it's not that unique. You know, some of the recon commands that they run can be pretty voluminous. So trying to filter through the noise can also be a challenge. Obviously, they're tailoring their activity and their file names and things to blend in. So they try and look like normal administrator utilities and binaries on a system. Process lineage is always challenging for us. As Jaron mentioned, you know, first thing yesterday morning with the development of Sprite Tree, you know, having real good process lineage is important for trying to analyze an intrusion, because if you're seeing recon commands being run, if you're not able to walk back the tree to see where they're coming from, then you're really not able to deduce much from that activity. So understanding, you know, parent and child process relationships can be very, very important for trying to tease these out. And then system irregularities, you know, with Macs being endpoint systems, users can do pretty much whatever they want on them. And again, things that you may think are unique maybe aren't so unique, or things that look really interesting end up just being a very entrepreneuring, you know, dev or system admin or things like that, you know, it just ends up being normal activity for that particular system. So definitely some challenges as we went through looking at these intrusions. A couple hunting opportunities that we'll leave you with. Some of these are kind of generic, right? I get that, but if you take these, you know, ideas into account with some of the command lines and some of the things that we showed earlier, you know, you can kind of put two and two together. So obviously hidden files, you know, you got a hidden file in the user's directory that may be a bit strange. Looking at where data files are residing, so, you know, running an swvers command, maybe, you know, not that interesting and very common, but if you're gonna run that and you're gonna output the output of that command to a hidden .log file in a /temp directory, then that might become a little bit more interesting. So looking for those kinds of things. Curl, right? So curl can be very noisy. You probably wouldn't see it on a normal end user system, but maybe a dev or a system admin, you know, you would. But again, looking at where curl's used to write the output. Where is it pulling down binaries from, and where is it putting those on the file system? Again, launch agent persistent, yep, I mean, we're all gonna look for that, but looking for, you know, newplists that are written to the file system, looking for nuances within the plist that maybe wouldn't be so common or you wouldn't expect. We talked about process relationship. You know, if you have good process trees and you can walk up a tree to see who the parent process of a certain command is, and it's not what you would expect, then that can definitely be a pivot point for you. And then the signing characteristics, which we've actually had a decent amount of success with, looking at the unique signing characteristics of binaries and using that to identify malicious activity in your environment. And that walks through the Labyrinth intrusion. So with that, any questions? We're happy to entertain. Any questions? Yes, sir.
Yeah, because it seems that there's threat actors targeting developers and engineers, and they're evolving fairly quickly. Have they started to target like collateral roles like a data scientist, or the devs use of premium resources like GPUs or more expensive cloud resources?
So your question is, are they targeting other users as well? Or?
Yeah, so you listed out I think there's about 5 roles, but I was just curious if they migrate from like these devs and engineers and then migrating to like collaborators, maybe like data scientists.
Yeah, right.
And their tool sets.
Yeah, I don't know if we've seen that specifically. I think they do, you know, move laterally from that initial host if they need to, if the permissions don't exist from that user to get to what they want. But I don't know if we've seen that specifically, like data scientists, or if we've been able to identify that based off of the EDR data that we have.
Okay. Yep. Okay.
Have you managed to build any detection for the North Korean adversaries, or is it all kind of noisy and manual?
I mean, you can talk. I mean, we have been successful at building hunting patterns for them based on some of the stuff that we've seen. They do like to reuse infrastructure, so that's been an easy hunt for us as well. But using some of the unique characteristics of the command lines that we've seen and the way they use their binaries has been beneficial for us. Yep. Thank you. All right. Thank you very much.
Super interesting.